Here it is, the latest armor for S30, or should I say, the advanced heat shield system featuring up to 18,000 tiles on S30. Over the past few days, SpaceX has been making some bold changes to this system, aiming for major improvements for the upcoming flight. Meanwhile, after a scrub that led to a week without any launches, Falcon 9 is prepped and ready to continue its quest to achieve this year's goals. If you're all set, let's dive into these thrilling updates in today's episode of Great SpaceX. Flight 4 wrapped up roughly 2 weeks ago, and true to their efficient style, preparations for the next flight are already in motion. During the June 6 flight, issues with the heat shield system arose, prompting Elon Musk to announce some revolutionary changes. These include plans to introduce a new heat shield, which promises to be twice as powerful as the current tiles, along with an additional ablative layer for extra protection. These upgrades are impressive, and the good news is, we won't have to wait long to see them in action. They are scheduled for immediate implementation on the next prototype flight, the S30, specifically on June 11th, just 5 days after Flight 4. The process of removing the old heat shield from S30 has already begun. Images from Starship Gazer show that this work involves the entire ship, including the nose cone, body, and flaps. A big shout out to Starship Gazer for these amazing images of the heat shield changes. If you're enjoying this video, consider following their team on X and subscribing to their YouTube channel to support their efforts in capturing more incredible images. Returning to the heat shield removal process, it's astonishing to see how quickly this task has been accomplished. By around June 14th, just 3 days after the work began, about 2/3 of the heat shields had been removed. In images taken on June 17th, we can see that S30 is now devoid of its heat shield, with only the stainless steel and attachment pins visible. This rapid progress is truly impressive, especially when you consider that each ship can have up to 18,000 heat shields. It highlights the high expectations SpaceX has for the Flight 5 prototype and showcases the efficiency and dedication of their team. Additionally, we can observe the ablative layer that Elon Musk mentioned. This appears as a white, cushion-like layer directly beneath the tiles, segmented into hexagon-like tiles, particularly visible on the nose cone. This segmentation is likely because the nose cone's heat shield is adhered with glue, unlike the rest of the ship, which uses the pin attachment method. Once the removal process is complete, SpaceX is expected to add a full ablative layer to S30. It's still uncertain whether this layer will cover the entire ship or only the most sensitive areas. Personally, I'm hopeful that SpaceX will opt for full coverage on all ships to ensure maximum safety. Following the ablative layer installation, new heat shields will be introduced. I'm particularly curious about the design of these new heat shields, touted to be twice as strong. Will they be thicker, or will there be a change in materials? Feel free to share your thoughts in the comments section down below. If work proceeds smoothly, I anticipate everything will be completed within 2 weeks, preparing S30 for testing early next month. Recently, Elon Musk responded to a tweet about Mechazilla, catching Starship by stating they aim to attempt this in late July with approximately a month remaining until then. Preparations need to be swiftly completed, including the replacement of the heat shield on S30. Once the ablative layer is installed, the next step is introducing the new heat shields. I'm particularly intrigued by the design of these upgraded heat shields, which are said to be twice as strong. Will they be thicker, or will there be a change in materials? Share your thoughts in the comments section below. Following this work, S30 will undergo another wet dress rehearsal test with Booster 12, or B12 for short. Additionally, I expect another static fire test to verify the reliability of the new tiles, possibly at the flame trench system at the Massey test site. Meanwhile, B12 will also undergo its own preparations, including a static fire and awaiting the full stacking of S30 for the wet dress rehearsal. I'm also eager to witness the debut of the booster's new hot staging ring soon. The journey to Flight 5 promises to be exceptionally thrilling. Please like, share, and subscribe to this video to support us through the upcoming period. Leaving Starbase, we turn our attention to Florida, where Falcon 9 is set to return after a relatively quiet week. This restart flight, named SCS-24, is scheduled to launch on the afternoon of June 18th, carrying SCS's Astro 1P payload to geostationary transfer orbit. You might wonder why I refer to it as a restart flight. That's because, before this mission, SpaceX hadn't conducted a launch for a week since the June 8th mission. Initially, SpaceX planned to launch a Falcon 9 carrying 22 Starlink Group 10 to 2 satellites from SLC-40 on June 12th. However, the mission was delayed to June 13th for unspecified reasons, and then postponed another 24 hours to June 14th due to adverse weather conditions. On June 14th, The launch attempt was aborted just seconds before liftoff during the ignition process of the 9 Merlin engines. While SpaceX didn't provide official updates about the incident, speculation suggests a Merlin engine issue might have been the cause. It's possible that a problem with one of the booster engines was detected only during the ignition sequence, prompting the sudden abort. SpaceX Senior Director of Launch and Recovery Operations Kiko Donev commented, "The tough week dealing with production challenges and then a rare scrub at engine startup yesterday on 10-2. Unfortunately, there is a real issue, so we need to go inspect the hardware in detail on this vehicle. The rocket will get set to the side, and we will pivot to SCS as the rocket and payload are ready to rock. Painful but safety and reliability are the priority." The recent incident is quite unusual for SpaceX. The last time they had to abort a mission during ignition was over 3 years ago, on October 3, 2020. Following the cancellation, SpaceX announced, "Just standing down from today's Falcon 9 launch. A new target launch date will be shared once available." The mission is now rescheduled for June 21. Thus, between the mission on June 8 and the upcoming mission on the 18th, SpaceX had a week without launching a rocket, which is uncommon for them. Typically, SpaceX conducts at least one mission each launch week. The last time there was such a gap was between 2 Starlink missions on December 8, 2023, and the 19th of that same month and year. Fortunately, SpaceX is now prepared to launch the SCS mission to end this hiatus. While mission aborts are disappointing, safety and reliability remain SpaceX's top priorities. The recent abort will certainly impact progress towards SpaceX's goal of 148 missions this year. However, SpaceX has a track record of overcoming challenges. As of the June 8 mission, SpaceX had successfully completed 60 missions, with May marking their busiest month ever, with 14 missions. With 5.5 months remaining in the year, SpaceX still needs to complete 88 missions. Historically, SpaceX accelerates its launch cadence significantly later in the year, making the goal achievable. Returning to the June 18 mission, it will mark the 61st Falcon 9 mission of the year. SCS, a long-standing SpaceX customer, is launching their Astro 1P satellite, a communications satellite destined for geostationary transfer orbit. The success of this mission is crucial for SpaceX to resume regular operations with this workhorse rocket. Shifting our focus east, China, currently the US's primary competitor in space exploration, has recently made significant preparations for the moon race. On June 14, China's primary space contractor conducted a successful static fire test of a rocket's first stage intended for lunar missions. The China Academy of Launch Vehicle Technology, or CLT, announced through its WeChat channel, "A Long March 10th first stage test article was fired in Fengtai district of Beijing Friday, June 14. The stage started normally, operated steadily, and shut down on schedule." The test article featured 3 YF 100K kerosene liquid oxygen engines and had a diameter of 5 meters. The full Long March 10th first stage is planned to be powered by 7 such engines, with 2 additional similar stages attached to its center stage. A second first stage power system test will be conducted soon to verify additional operational conditions. This successful test marks a significant advancement toward China's goal of sending astronauts to the moon before 2030. In comparison, NASA aims to achieve this milestone with Artemis 3, slated no earlier than 2026. The Long March 10th rocket comprises 3 stages, measuring a total length of 92.5 meters. Its first stage utilizes 3 cores with a takeoff mass of 2,189 tons and a thrust of approximately 2,678 tons, designed to transport payloads of at least 27 tons to Earth-Moon transfer orbit. 2 Long March 10th rockets are planned for missions carrying spacecraft and landers to the moon. As a direct competitor to NASA's Space Launch System, SLS, and SpaceX's Starship Human Landing System, HLS, the Long March 10th positions China prominently in the future lunar exploration race. With this development, anticipation grows for new advancements from SpaceX and NASA, especially as the Artemis mission draws closer. Well, folks, that's about it for today's episode. Thank you so much for tuning in, and as always, this has been TMV from Tech Trend Whisperer. Until next time, keep looking up.